Okay, welcome back. Chapter 50 in Hazardous Materials. So in this chapter, we're just going to kind of take an introductory approach to hazardous materials. It's really nothing earth-shattering from your EMT training, but this should serve as a pretty good refresher for hazardous materials. Realize this is not an awareness level class. That's a much more in-depth class. This is just kind of a topical review and an introduction to some information that's related to hazardous materials that everybody in EMS should be aware of. Okay? So when we're talking about hazardous materials, we're referring to any substance or material capable of posing an unreasonable risk to human health, safety, or the environment when transported, used incorrectly, or not properly contained or stored. We produce, transport, store, use, and dispose of tens of thousands of different types of potentially harmful substances annually. So operating at the scene of a hazardous materials incident presents a very unique set of challenges not typically found in your routine EMS call. Of course, these challenges are going to include the risk of exposure to toxic substances, and all the way up to the extreme of potentially becoming a victim of those toxic substances yourself. So you must be capable of handling these types of exposures properly and confidently so that you yourself don't wind up, being a victim of that or creating future, additional victims at a scene. So there are some standards, regulations and standards to be aware of. Regulations for hazmat response are created by OSHA, the Department of Transportation, as well as the EPA. They came out with a document, and it's called the HAZWOPER document. It references hazardous waste operations and emergency response. So this document kind of outlines how we would respond to hazardous materials incidents and what competencies are needed. So it kind of defines what hazmat response is. Within that document, they recognized the different training levels of hazardous materials personnel, or HAZWOPER training levels, the first of which is awareness. That particular course is about an 8-hour long course. It's fairly in-depth, but it's not stringently in-depth. And then from that, you have hazmat operations and hazmat technician, and then hazmat specialist. As you can imagine, the training for each of these gets a little bit longer. Hazmat ops and technician, I believe those may be both around 40 hours as two separate classes. And then specialist and incident commander is going to build on those courses as well. I believe, I'm not 100% certain, but some of those, like technician, specialist, and incident commander, are going to require that you have at least an operations level knowledge before you can take those courses. So awareness is just that. It's awareness. Operations is kind of the foundational course, and then you kind of build on top of that operations course. First responders, of course, most all of us should be at the awareness level so that we can understand what hazardous substances that we may be dealing with, as well as the associated risk that those substances may have. They should also, as first responders, understand the potential outcomes of a particular incident. Awareness level responders must recognize the presence of hazardous substances and identify them if possible, because the idea is if you're at the awareness level, you want to warn the additional responders that are coming, as well as kind of get the cavalry, the hazmat cavalry coming, to be able to manage that incident. They also need to understand their role in the emergency response plan. And finally, awareness level responders should determine the need for additional resources. So as I've mentioned, you're going to be the one that's kind of calling in the cavalry if you're one of the first ones there. So there's this thing called consensus-based standards that can actually kind of help guide responders as well. All EMS personnel should receive appropriate hazmat response training. So we're not talking about what this little chapter is that we're going to cover in, maybe 45 minutes or an hour total. We're talking about a comprehensive course, either at the awareness level or on up. So it's recommended that everybody should receive hazmat response training. Of course, this is going to be based on the needs and requirements of whatever jurisdiction you're working under, and even your agency that you work for. So if you're fire-based, you're going to have a certain expectation of a level of care. If you're non-fire-based, there's still some expectations there, but it may be different than fire-based. So if you work in a city that has a large chemical factory, the need for you to maybe have something beyond the awareness level of training may exist as well. If you work in one of those corridors where a lot of hazardous chemicals go up and down the highway, it would necessitate, at least having an awareness level of what you're getting into when you're responding to emergency vehicle crashes. So there's also some federal, state, and local regulations and standards that govern the use and storage and transportation of hazardous materials. So there's regulations, not only, there's some guidelines, not so much regulations for EMS personnel, recommendations that we should follow so that we have an understanding. But these are also based on these regulations and standards that are put in place by governing bodies that regulate the storage and transportation of these hazardous materials, because by knowing what those guidelines are, it's going to make it a whole lot easier for us to do our job and recognize when there's some kind of substance that may be harmful milling about at our scene. So when on the scene of a hazmat incident, it's really important that we rely on our training and reference sources to help us respond. So we should have access to those things that are going to help us get a clearer picture of what it is that we're dealing with. And we also should know how and when to access specific toxicological information from reference materials such as the Poison Control Center, medical control, or even from the hazmat team when we're dealing with the patients that we're taking care of. Understand how a hazmat scene is organized from command and control perspective, and where you fit in, what's your role in that. And then you want to make sure that you're familiar with the different types of personal protective equipment, how the patients will be decontaminated and to what level, and how to access or how to assess and treat their exposures, what they've been exposed to. A hazmat incident may not necessarily always happen in a factory. It may be on the highway, it may be a railroad incident, it could be a substance leaking from a cargo tank. It could also involve a leak, a fire, or other emergency in an industrial plant, refinery place, or other fixed facility where chemicals or explosives and those kinds of things are either produced, used, or stored. A hazmat incident may be a leak or rupture of an underground gas or natural gas pipeline or other kind of pipeline. Incidents in the agricultural setting where fertilizers, fuels, waste products, insecticides, or other materials may be used or accidentally released are also potential for hazmat incidents. The buildup of methane or other byproducts of waste decomposition in sewers, sewage processing plants, or landfills can result in a hazardous materials incident. Incidents occurring during the manufacture of illicit drugs, including leaking of toxic substances or combustion of chemicals like hydrochloric acid and potassium, are considered a hazardous materials or a hazmat incident scene. An incident with criminal or terrorist intent, which is a suspected hazmat agent, is intentionally released as also is a hazmat incident. So oftentimes terrorists will utilize those things that are hazardous as a means to, an end to whatever it is that they're trying to spread, whatever the terrorism they're trying to spread. So when we're sizing up that scene, we want to make sure that we're safe, us and our partner are safe. It may not be possible to identify all of the hazards present, and some hazards may come to light as that scene progresses and maybe even sometime afterwards. But there can be some warning signs to keep a lookout for, such as signs and symptoms from our victims, along with maybe even placards or labels, and other clues that might give us an indication of what it is that we're dealing with in that particular incident. You should maintain a high index of suspicion when you're doing your scene size up. You may very well be called before you have a firm grasp on what is happening. So you may be well into that call, well taking care of your patient before you realize that there's a hazmat incident. For instance, you respond to a family developing sudden nausea and sickness and headache and all those kinds of things. You show up and realize very quickly that it's a carbon monoxide poisoning. That is an actual hazardous materials incident, and it needs to be treated as such. So sometimes you find yourself in the middle of those before you actually know you're in the middle of those. You may be able to help to identify leaks and spills by visible cloud or strange looking smoke or vapor. A leak or a spill from a tank, a container, truck, railroad car, or an unusual, strong, noxious, acrid odor may be an indication that there's something not right. Keep an eye out for placards and labels, because they can be found on buildings or areas where the hazardous materials are produced, used, or even stored. Trucks and railroad cars that transport certain types and amounts of hazardous materials, or dumps or other storage vessels that contain hazardous waste will be identified by these placards, so long as the rules and regulations are being followed. Some chemicals are intentionally odorized to indicate the presence of normally odorous gases, such as propane and methane. And some chemicals can only be detected by air monitoring instruments, for example, as I mentioned, carbon monoxide. Never rely on your sense of smell to identify the presence of hazardous materials, because it could fool you. You should suspect the presence of hazardous materials if you approach a scene where more than one person has collapsed, is unconscious, or is in respiratory distress. If we have multiple people with a sudden onset of signs and symptoms, we should suspect that there's some sort of environmental issue going on, and it should automatically make us lean towards the potential presence of hazardous materials. Proper safety measures during these incidents are essential. There will be times when the EMS crew is the first one on the scene. It often happens that way, especially in our more rural scenes. If you notice any signs suggesting that this may be a hazmat incident, you should stop right there. Make sure you maintain a safe distance upwind and uphill from the scene until you can determine whether or not that scene is safe. After rapidly sizing up the scene, isolate the hazardous area as best you can by denying entry to the affected area and calling for additional resources. Once your safety is ensured, you may begin assessing victims and initializing patient care as appropriate. If you do not recognize the danger until you are too close or in the midst of it, leave the danger zone when you recognize that. Don't stay there, pull out, get out of the danger zone until that area is determined to be safe. Once you got an idea of what's going on, you need to be sure to provide as much information as possible when you're calling for additional resources. For instance, if you know you've got a hazardous incident, a hazardous spill that is an issue, knowing what that particular substance is that you're dealing with can be very, very helpful to say the fire department that's going to be responding to that spill, if they don't necessarily have the resources to manage it correctly, but a neighboring agency does, they can reach out to that neighboring agency and get them on the way as well. So reporting what it is you're dealing with is really, really essential, because sometimes there's state resources that a local department may not have available, and the state can begin to respond to that, or a much larger agency can begin to respond to that. That's especially true in our more rural parts of the state. Of course, the information should include where you're at, your exact location, the type and number of additional resources that you need, and the exact name of the substance if you know what it is, and the approximate number of victims, including the severity of their injuries. Also report any signs, symptoms, and effects that you're observing that may be related to that toxic substance. The size and shape of vehicles or containers is helpful. Chemical ID numbers or symbols that are visible. Atmospheric conditions, such as, is the wind blowing, is it raining, or anything like that. The location of the safe staging areas for incoming resources, and the location of the incident command post, if those are created yet. Once those are created, that'll be really, really helpful to know that, especially if you're calling in for additional transport vehicles, additional ambulances. They're going to need to know where to go. Do not re-enter or leave the area until a hazmat team clears you. So you're not gonna, if you're in there and you know you've been contaminated, you don't leave that area until you've been cleared by a hazmat team. Of course, don't enter that area for, fear of being contaminated. So how do we identify what we're dealing with? The information that you're going to obtain is going to come from things as simple as observations, reports from bystanders, as mentioned earlier, maybe some signs and symptoms that the victims are displaying. Labels and placards are a big indication and a big help a lot of times, but sometimes those are not always visible. Sometimes in accidents such as derailments or motor vehicle collisions and those kinds of things, sometimes those placards get dislodged, or they're in a location that is now covered that we can't see, so we can't rely completely on those. Shipping papers and safety data sheets. Sometimes if you're able to get in contact, or if you're able to talk to the person that was maybe driving the vehicle or in charge of the vehicle, whatever that may be, they should have an idea of what it is that they're transporting as well, that might be able to help you narrow things down. Every emergency vehicle, police cars, fire trucks, ambulances, every single emergency vehicle should keep the most recent edition of the Department of Transportation's Emergency Response Guidebook handy. It should be kept in every one. Every single vehicle should have this. This book is super, super handy at helping to identify what substances that you're dealing with, and it kind of breaks down what those placards mean and the shapes of vehicles and all that. We're going to talk a little bit about that. But this book contains a whole lot more information in it, and as I've mentioned, you'll spend an awareness class is a lot more information than what we're going to cover in this chapter, and that awareness class covers a lot about what this ERG has in it. Of course, the ERG is going to provide information on specific properties of hazards and substances, what is shown on placards, and the recommended isolation distances for whatever substance that you're dealing with. There are 9 DOT chemical families recognized in the Emergency Response Guidebook. They include Class 1. These are all the families, all 9 of them. We'll go through them. Class 1 is explosives. Class 2 is gases. 3 is flammable and combustible liquids. You would think that would fall into explosives, but we're talking about a little bit different. While flammable and combustible liquids may explode, it's not necessarily the same thing. Flammable and combustible liquids are things like gasoline and that kind of thing, which are capable of exploding to a degree, but not quite like dynamite. So that's where the difference is. And then you have flammable solids, spontaneously combustible materials, and dangerous when wet materials and water reactive substances. So there's some substances that kind of fall into that category as well, and I kind of got a little, kind of made me chuckle a little bit when it was spontaneously combustible materials, because the only thing I could think of there was, when hay gets wet and it's stored in a barn and it'll spontaneously combust. I'm not sure it would be considered a class 4 DOT chemical, but it will combust. Class 5 is going to be those oxidizing substances or organic peroxides. 6 is toxic substances and infectious substances. 7 is those radioactive materials. 8 is corrosive. 9 is miscellaneous, where if it don't fit somewhere, it's going to go in miscellaneous. And it could be substances or even organisms too. So it's not always just a chemical. That's one thing we need to realize too. It's not always just a chemical. It can be an organism. There's a skill drill that's in this chapter. It's the very first skill drill, and it kind of outlines how to use the emergency response guidebook and how to find what you're looking for. Obviously, in a video presentation lecture, you can't really do any hands-on in it. So the best way to get familiar with the emergency response guidebook is to get your hands on one and begin looking through it. It will start to make pretty good sense, but it's really helpful for you to be familiar with that, so you know exactly what section to go to find what it is that you're looking for. If you're looking at a particular placard and it's got a number on it or something like that, and you're like, I don't know what that means, knowing where to look in the guidebook is going to be really helpful for you to find the information relatively quickly. There's a transportation marking system that's really, really helpful. And of course, as I've mentioned, the labels, placards, and markings kind of thing. Well, that's what I've been referring to, is this system that gives us an insight into what that particular chemical is, if it's known. Obviously, a terrorist or something along those lines is not going to put a placard on their device that they're trying to harm people with. So, if it's a company or something like that that's transporting something, or a business that has stores chemicals or uses chemicals, they will have this because they have to be in compliance. But it's not a guarantee. Someone's cooking meth in their meth lab, probably not going to have placards and labels on things that's letting us know the dangers of them. I'd be impressed if they were, but probably not going to happen. So they use this marking system when materials are being transported within the United States, and that same marking system is used in Canada. It's very similar to the system that's used for facilities. There's a lot of kind of crossover, so you'll see some kind of similarity when we talk about the ones used in facilities. It's a little different. Here's an example of the placards that are commonly used. You can see the different ones here. It's not unusual, like this particular container here has 5 different ones on it. It's not unusual for that to happen because many of these containers are compartmentalized, so they can carry multiple compartments or multiple different things on that particular vehicle. You can see 2 of the placards on this one are the same, but 3 of them are red, 2 the same, 1 is a little different, so you can kind of surmise from that it's carrying different substances, and the others are a little different too, and they look like maybe corrosive. So these are a diamond shaped, and they're placed on all 4 sides of a vehicle carrying hazardous materials. So we should find it on all 4 sides of that vehicle. They'll identify a broad hazardous class of the material, such as flammable, poison, or corrosive. And the most common used in the United States, these are the most common placards that are used in the United Nations and North America coding system. Many of them will show a 4-digit number for a more specific hazmat identification like we see on these placards here. It'll give us a better idea of what particular flammable substance we're dealing with, for instance. Labels, of course, are smaller versions of placards. They're placed on individual boxes and smaller packages being transported, referring only to the potential hazards that that particular box contains. It's probably not going to give us what's specifically inside of it. There might be another label on there that does that, but this placard is going to be something we can see from a distance and go, okay, that's got a hazardous substance in it and it falls in this category. It doesn't require, the DOT system, however, doesn't require that all chemical shipments be marked. Most often, if it's a certain amount of a hazardous material, then it's going to need to be marked with a placard. However, it's under that particular, that amount, it doesn't need to be marked. You may also identify hazmat transport from the bill of lading or the freight bill carried in the truck and the driver of the cab. This may be a lot more difficult for us to get our hands on if we're trying to identify something from a distance. But it could be that, you know, the hazmat response team tries to get into that truck and find out what it's carrying. Additional resources that we can use would be the way bill or the consist, which is carried by the train conductor, or the dangerous cargo manifest in the ship's wheelhouse, which we don't have much shipping in Oklahoma, and maybe an air bill carried by a pilot for a hazmat transported by air. So there's going to be other ways that we can identify that. Sometimes the company itself might be able to help identify what's there, but that's going to take a little bit longer. For instance, a trucking company may have, you know, hundreds or 1,000 or more trucks transporting things across the country, and that maybe some companies are specifically designed to transport hazardous materials, so it may be a little bit trickier to narrow down which truck that is and what that particular truck was carrying. But there's multiple ways to kind of help to determine what we're dealing with. Realize that these may not happen quickly. Dispatchers can sometimes also assist by collecting more information from organizations like Chemtrek. Chemtrek, I believe, actually has an app that you can use on your phones. Chemtrek is an extensive database of chemical information for emergency responders. Of course, when calling Chemtrek, you need to make sure that you have the name of the chemical involved, the name of the caller, and whoever, you know, your name and a callback number, the location of the actual incident or problem, the shipper or manufacturer of the chemical if you know it, the container type, if there's any kind of rail car or vehicle markings or numbers, if you know the shipping carrier's name, who's receiving the materials, local conditions, weather conditions and whatnot, and the exact description of the situation when you reach out to Chemtrek. Now, you may not know all of that information, but you want to be able to give them as much information as possible, because then they're going to be able to kind of help you respond to that incident and give you a better idea of what it is that you're going to need, you know, maybe what decontamination procedures are and cleanup and all that kind of stuff. They're going to help with that a lot. Fixed facility marking system, as I mentioned earlier, similar to the placards. This kind of follows the NFPA 704 standard for identifying hazardous materials. And it identifies a marking system for fixed facilities. It uses a very similar placard system, similar in some ways, with a set of diamonds found on the outside of buildings, doorways, and chemical storage areas, and even fixed storage tanks. We've probably all seen these when we go into a factory building or factory, someplace like that, and there's a placard on the door. Doesn't necessarily mean that on the other side of that door all of those things exist immediately in the doorway. It just means that building has those things in it somewhere. And there may be multiple on the door, because there may be multiple different things that you need to be aware of. Of course, this diamond-shaped symbol is broken down into 4 smaller diamonds, each representing a particular property or characteristic. So they'll all be pretty standard: red, yellow, white, and blue. And the red would be for fire hazard, blue is health, white's for special information, and yellow is a reactivity hazard. Then each smaller diamond has a rating scale on it from 0 to 4. 0 is no hazard, 4 is severe risk. There may be multiple chemicals stored in that building that are a fire hazard, but what they'll do is whichever one of those chemicals has the highest rating of a 4, that's the number that'll be on the door. If all of them are a 1, or say there's a 1, there's a 2, and there's a 4, the number on the placard will be a 4, indicating that there is that high of a hazard in there. Now that doesn't give us any kind of indication of the quantity of what's in there, or anything along those lines, but it lets us know that those things exist inside of there. So it's will help us kind of when we're responding to that. So permanent manufacturing or storage facilities will have safety data sheets, and this will give us some in-depth information that can help us respond to that and potentially save lives. Safety data sheets provide information on the substance's chemical makeup, potential hazards it presents, appropriate first aid in case of exposure, and other data information for safe material handling and those kinds of things. So those can be really, really helpful, and there are many places are required to have those. So let's talk a bit about containers. Containers are any vessel or receptacle that holds a material is considered a container. This type, size, and material of the container can provide clues about the substances that may be inside of it. Often there's no correlation between a drum's color and its possible contents. Examples of how hazmat is packaged, stored, and shipped include steel, polyethylene drums, bags, high-pressure gas cylinders, railroad tank cars, plastic buckets, above ground and underground storage tanks, cargo tanks, and pipelines. So there's a whole laundry list of ways that things are stored and transported. Containers are divided into two categories based on their capacity. There's bulk storage vessels and non-bulk storage vessels. Bulk storage vessels include fixed tanks, highway cargo tanks, rail tank cars, totes, and intermodal tanks. These vessels are found in buildings that rely on and need to store a large amount of particular chemical. And then, of course, there's secondary containment, is an engineered method that controls spilled or that helps to control from spills or release products if the main containment vessel fails. So there's almost always a backup system to these bulk storage vessels, ways that we can keep them, or hopefully keep them from leaking. Large volume horizontal tanks are common. These tanks include both above ground and underground storage tanks. They can hold a few hundred gallons to several million gallons of a product and are usually made of aluminum, steel, or plastic. Typically the way those work is most of them are double lined, double walled. So if the one wall fails, the other wall will hopefully catch that. Then we have totes. These are also pretty common and referred to as intermediate bulk containers. They hold anywhere from 119 to a little over 700 gallons. Totes are portable plastic tanks surrounded by a stainless steel web that can contain any type of chemical. So the plastic tote sits inside of a stainless steel container. They present hazardous shipping and storing conditions because they oftentimes don't have a really good secondary containment system. So you've got a plastic tank surrounded by metal, which is hoped to hold that in. The problem is if the metal leaks too, there's no way to catch that. It's very difficult to patch the leaks on these steel tanks, or on the plastic tanks, because of the steel webbing around them. Makes it very difficult to make any fixes. Intermodal tanks are used for both shipping and storage. They hold 5,000 to 6,000 gallons of product and can be pressurized or non-pressurized. The image on this on your screen there shows a pressurized tank, and you can usually tell that because it's rounded ends. you typically indicate a pressurized tank. How much pressure? I have no clue. It could be a low pressure tank or it could be a high pressure tank, but typically that's an indication of a pressurized tank. Not guaranteed though, it could be unpressurized. It could be not necessarily a pressurized tank, but your pressurized tanks will be rounded. These tanks like this one are usually shipped, maybe stored, and then returned back to the shipper for refilling. They may travel by air, sea, or land. There's a lot of different ways that these can be transported. Non-bulk storage vessels hold a few ounces to 120 gallons of product. They include drums, bags, compressed gas cylinders, cryogenic containers, solvents, industrial cleaners, and a various degree of compounds. Drums are barrel-like containers that store a wide variety of substances. They're either made of low-carbon steel, polyethylene, cardboard, stainless steel, nickel, or other materials depending on what the contents are. The drum's construction depends on the nature of the chemical. Steel holds flammable liquids and cleaning fluids, oil and other non-corrosive chemicals. Polyethylene is going to hold your corrosives, acids, bases, and oxidizers. Cardboard's going to hold more solid materials. Stainless steel is going to hold materials too aggressive or too reactive for storage in other types of containers. So it's going to give you somewhat of an indication of what may be inside of it. It's not a guarantee though. Bags are used to store solids and powders constructed from a plastic. They can be constructed from plastic, paper, or plastic lined paper. Pesticide bags provide specific information such as the product name, active ingredients, hazard statements, total amount in the container, manufacturer's name and address, EPA registration number, and EPA establishment number. So of course the establishment number shows where it's manufactured. Pesticide bags also feature signal words indicating the relative toxicity, such as danger, poison, high toxicity, danger, severe eye, skin irritation, warning, moderately toxic, or caution that it's minorly toxic. Other pesticide bag information is going to include practical first aid treatment, directions for use, ag use requirements, precautionary statements, storage and disposal information, a classification statement on who may use the product, and a keep out of reach of children statement. So there's going to be lots of information on these pesticide bags. Carboys transport and store corrosive and other chemicals. This is a container made of glass, plastic, or steel capable of holding 5 to 15 gallons of product. It's typically surrounded by a wood, foam, or fiberglass or steel box for protection. Cylinders can hold liquids or gases. Various substances are stored in uninsulated compressed gas cylinders. And of course, the cylinders may vary in size. We're all familiar with the fact that there's varying sizes of cylinders that contain gases. We carry our oxygen cylinders on the truck. The most common method of hazmat transportation is going to be over land. So we see these trucks going up and down the highway. It doesn't have to be a tanker truck to be hauling hazardous chemicals. It can be a regular cargo truck, a semi with a box trailer on the back. A cargo tank is a bulk package that may or may not be permanently attached to a motor vehicle. Could be on a train. A cargo tank can be loaded or unloaded without being removed from the vehicle. So typically it stays on the vehicle and it gets to its destination and it's unloaded, or it's taken to the manufacturer and it's loaded. This is an example of one of those. This is a flammable liquid tanker. It's one of the most common ones that we see, and it's a pretty reliable transportation vessel. It's going to transport liquid. This one here is going to transport liquid food grade products, gasoline, or other flammable and combustible liquids. It's an oval shaped tank pulled by a semi truck. It can carry between 6,000 and 10,000 gallons of product and is non-pressurized with a working pressure between 2 and 4 psi. The tanker is made of aluminum or stainless steel. Its safety features include a full rollover protection cage and remote emergency shutoff valves. These are pretty robust tanks, but they can get broken in an accident. This is a chemical hauler. It's similar to the last one, but it's a rounded kind of horseshoe type shape that it has instead of the oval shape. It holds 6,000 to 7,000 pounds of gallons of liquid. Of course, it's pulled by a truck as well. It's going to contain flammable liquids, mild corrosives, and maybe some poisons. It may be insulated or uninsulated and can have a higher internal working pressure of up to about 35 psi. This is a corrosive tanker. It's commonly used in transporting corrosives. It's smaller diameter than the other two, and it can be identified by several heavy-duty reinforced rings around the tank, which provide structural stability during transport or rollover. So you can see these tanks are a lot more robust than the others. Operates at about a 15 to 25 psi rating and holds about 6,000 gallons. So a little bit less, but it's more heavily reinforced because of the contents of it. We want to keep them inside. This right here is a pressure tank. It's going to carry things like ammonia, propane, freon, butane, those kinds of things. It's going to vary from 1,000 gallons to 11,000 gallons. Notice the rounded ends on this, and these are constructed of either steel or stainless steel. It's going to feature a single tank compartment inside of it, and it's going to operate at approximately 300 psi. There is an explosion hazard if the cargo tank is loosened or comes impinged by fire, so there is a risk. Realize that, if fire heats this tank and it gets above the burst point of the tank, whatever that is, these are rated for 300 psi, but they typically can handle more than that. But once it reaches that burst pressure, it will burst, and if the contents of that are flammable, they will ignite. This is a cryogenic tanker. It's a low pressure tanker that relies on tank insulation to maintain the low temperature required for cryogens. The control valves are usually in a box-like structure on the rear of the tanker. And of course, you must have special training to operate the valves on all of these tankers, so don't try to do it yourself. Leave them alone. So small puffs of white vapor are vented from the control valves, which is normal and not indicative of an emergency. So it's not unusual for these to, off gas or vent something. Tube trailers can carry compressed gases like hydrogen, oxygen, helium, and methane. These are high volume transportation vehicles made up of several individual cylinders band together and affixed to the trailer. They operate at working pressures of 3,000 to 5,000 psi. One trailer can carry several different gases in individual tubes. The valve control box is usually found at the rear of the trailer. Each individual cylinder has its own relief valve. Dry bulk cargo tanks carry dry bulk goods, as you would suspect, such as powders, pellets, fertilizers, and grain. These tanks are not pressurized, though they may use pressure to offload the product, and they are usually V-shaped with rounded sides, so you can kind of see how everything kind of comes down, funneled kind of down into a drop point so that those can drop out. That's usually an indication that it's a dry product that's in it. Of course, any one of these is going to have some kind of labeling, placard labeling, if it's containing hazardous materials. All right, so that is the end of part 1 of chapter 50 in hazardous materials. We will finish this chapter up in part 2, where we talk a little bit more about hazardous materials. So I will see you guys back in part 2.